Assalamualaikum warahmatullahi wabarakatuh, and we meet again in lecture number 8, and we are still in same topic, which is under CO2 torsion, and this is BMM 1533 strength of materials for section number 1. The objective of a chapter objective for this subject is to analyze the circular and non-circular members problem which are subjected to twisting couples or torque. Okay. So basically this lecture is a continuation from lecture number 7. In previous lecture, which is lecture 7, we have learned on how to calculate the value of shear stress due to torsion. So now, since the shaft itself will be twisted due to torsion loading, torque loading, and therefore, of course, it will have a angle which is known as angle of twist. So if you refer to this figure here, the phi, symbol of phi, is represent for angle of twist, and along the way, if you keep twisting the shaft, so the angle will keep increasing in value. So how can we calculate the value of angle of twist? Before that, this is how you determine the positive and negative value of angle of twist by using a rule of thumb. Okay. And so the formula for angle of twist is phi equals to TL over JG. And the cutting section is the same as in previous lecture. Because since you need to determine the location of torque loading at each section, and from there you need to cut each section. So by right, for this shaft, you have 1, 2, 3 section, and therefore to find the value of angle of twist of phi here, we need to summarize all the TL over JG acting on the whole shaft. For example, for this figure, now the first section is TL over JG for section AB plus TL over JG for section BC plus the section TL over JG for section CD. So by right, you need to find the value of torque for each section. So cutting from A and before exactly point B, there you get this free body diagram whereby torque acting on AB is equals to 80 Newton meter. After that, cutting from point A until before point C, you'll get this free body diagram, which is we need to find the value of torque acting on BC, and from here you'll get the value of TBC equals to negative 70 Newton meter. For this angle of twist, you need also be consistent with the value, with the direction, because like have been stated in the previous slide just now, you need to follow the rule of thumb there. So that one will refer to negative and positive value of the angle. After that, after that, we need to find the value of torque acting on section CD. You can either cut from A until before point D, or you can cut from point D until exactly before point C here. So to make our life easier, so we can cut from D until exactly before point C. You'll get the value of, you can get the value of torque acting on CD is equals to 10 Newton meter. By right, if you cut from A until exactly before point D, you should have the same value of torque. Okay, so this one, torque CD equals to negative 10 Newton meter. From there, just substitute into the formula, and finally you get the value of angle of twist for point A by referring to point D. Now let's look at to our example. Let's read it together. The horizontal shaft AD is attached to a fixed base at D and is subjected to the top as shown in figure below. A 44 mm diameter hole has been drilled into portion CD of the shaft, CD. Knowing that the entire shaft is made of steel for which G equals to 77 gigapascal, determine the angle of twist at end A at this point. So by looking at this diagram, we know that C and D is a hollow shaft. And the question asks you to find angle of twist at end A. Now, the first step is that we need to determine the reaction torque acting on each section. So this one at point A, taking moment in x-axis, so we'll get TAB torque at section AB equals to 250 Newton meter. Moving to the next section, because there's a change in dimension, and also there's a other torsion acting on that section, and therefore we need to cut the other section. From there you'll get torsion acting on section BC is equals to 2250 Newton meter. And since there's no torque applied in section C, and therefore the torsion for section CD equals to torsion acting on BC, which is equals to 2250 Newton meter. And for each section, the value of J is different, because this one is small, even though it is solid, but it is smaller in size, and therefore we need to find the value of J, or polar moment of inertia, for each section. For example, J for section for AB, for shaft AB is pi over 2 r power of 4. Then substitute the information into the formula, you get the value of J for AB. Same goes to other types of shaft, which is JBC and JCD. After that, angle of twist phi equals to TL over JJ, and we know that there are three sections there, section AB, BC and CD. So you just substitute all the information given into this formula, and from this calculation you get the value in radian, and therefore you need to change into degree in order to get the value of angle. So you get here angle of twist at point A equals to 2.31 degree. Okay, so that will be all for today's lecture. So we will meet again in the next lecture, which is lecture 9. Thank you very much for your kind attention and time. We shall meet again. Thank you and bye-bye.